Hello my dear students. So I am going to continue with the extra questions related to changes of matter, that is the 16th lesson of your grade 10 science textbook. In the previous chapter I discussed some questions. Those were the MCQ type questions. So now I am going to move on to extra question 2. Given below is an apparatus prepared by a group of students to collect hydrogen gas in the laboratory. So you can remember students, when we discussed the lesson, we discussed preparations of three gases: hydrogen, oxygen and carbon dioxide. And also I did the activity in the laboratory as well. So you're familiar with the observations, the chemicals that are used to produce the gas, how we collect the gas and what properties used to collect the gas. All that is familiar to you. So here they have given us the setup, the apparatus that is used to collect hydrogen. So first we will look at the apparatus. Now can you all see here students? You are familiar with this diagram. Now you can see the conical flask that is labeled to you. Inside that you can see the zinc granules. So you can remember, when we collect hydrogen gas, usually it is the reaction between a metal like zinc, magnesium with either dilute hydrochloric acid or dilute sulfuric acid. Then there is hydrogen gas liberated. That is the reaction we use. So inside the conical flask there is zinc granules, and then here you can see Y is what is shown as Y is the thistle funnel. You can remember that. Through the thistle funnel only we pour the hydrochloric acid solution, but here you can see, as you look at the diagram, you can identify a mistake. So remember students, when they give you a diagram where there is a mistake in it, in one of the questions they will ask you to identify the mistake, or they will tell you to redraw the diagram correcting the mistake. So you should be able to see that there is a mistake. What is the mistake here? The thistle funnel has to come right down to this part so that the acid directly falls on the zinc granule, and also the gas that is liberated does not enter into the thistle funnel. So for two purposes. And at the same time, you all can remember students, the delivery tube. What is a delivery tube? A glass tube initially, and then we can connect a rubber tube, or it can be a glass tube only. So through the delivery tube only, the gas liberated will be transferred to this side of the apparatus. So there, the delivery tube has to be slightly above. The thistle funnel has to come down and the delivery tube has to be above. Then you can see the delivery tube, and then here you can see this is a trough containing water, and X is actually the beehive shelf. You can remember that. And I have shown you all a beehive shelf. It's a round structure like a small stage. On top also there is an opening. On the side also there is an opening, so that we can easily direct the gas into the gas jar shown there. So then you can see this is the gas jar. Normally when we take the gas jar, you can remember students, we have to fill it completely with water so that there is no gas or air bubbles trapped inside it. We will collect the gas in the pure form. So then when the gas is being collected, the water is displaced down. That is why we call it the downward displacement of water. So here you can see hydrogen gas is collected up. So we know all the materials, the glassware, equipments and the substances used in this apparatus. I am sure you can remember those. So let's look at the questions now. So like you always do students, I am sure you would have already read the questions and you would have answered them, and now you are checking your answers with my discussion. So then, the first one, identify the apparatus X and Y. We have already done that. What is X? X is the beehive shelf. And what is Y? Y is the thistle funnel. Through the thistle funnel only, we add the hydrochloric acid to this, or sulfuric acid into the conical flask. Then the second one, What is the chemical substance added to the conical flask through apparatus Y? So that is just what I said. So it is the acid. So it can be dilute hydrochloric acid or dilute sulfuric acid. So what is the chemical substance added to the conical flask through apparatus Y? So we can say dilute hydrochloric acid. If we want, you can even write the chemical formula of that. Dilute hydrochloric acid. You can also write dilute sulfuric acid. Then the third one. Write the balanced chemical equation for the reaction taking place in the conical flask that liberates hydrogen gas. So, based on what acid you write here, you will have to write the equation. So, here I have written dilute hydrochloric acid. Then you know the reaction. Zinc reacts with hydrochloric acid to give rise to zinc chloride and H2 gas. And what do you need to do? You need to balance it. How do we do that? Now, zinc 1, that looks balanced. Hydrogen 1, but H2 gas. And chlorine 1 atom, here there are 2 chlorine atoms. So, first what do? We put a coefficient 2 in front of HCl. So, now that is balanced. 2H, 2Cl, so 2Cl and 2H there. And zinc only 1. So, now we have written the balanced chemical equation. I am sure you all can remember this. Now, in case, if we have written the acid as dilute hydrochloric acid, how will you write the equation? So, as a note, I will write it here. If the acid is dilute sulfuric acid, then you will have zinc plus H2SO4 giving rise to zinc sulfate plus H2 gas. Always the salt is produced and hydrogen gas is liberated. So, is it balanced? Zinc, H2, sulfur, O4. So, it is a balanced chemical equation. So, this is, if you write the acid as dilute sulfuric acid, you will give this equation. Otherwise, what we have written here is correct. So, I am sure students, you were able to answer these correctly. So, we identified the 2 glasswares, beehive shelf and the thistle funnel. Then the acid is dilute hydrochloric acid and the reaction. I'll move on to the next part of the question. The fourth one. Write the name of the method shown in the diagram to collect hydrogen gas. What is the name of the method? There it is the downward displacement of water. So, the name of the method is downward displacement of water. That is the name of the method. What is the other method we can use here? Downward displacement of air. Why? Because hydrogen is less denser than air. So, hydrogen will go up and air will be pushed down. So, we can either use downward displacement of water like shown here, or we can use downward displacement of air to collect hydrogen gas in the laboratory. So, you are familiar with that, students. Then the fifth one. A student said that the way in which the apparatus Y and the delivery tube have been connected to the conical flask is wrong. So, this is what I told you. Use a diagram to illustrate how they should be connected. So, you need to draw the diagram. So, there of course, you don't have to completely draw the diagram, students. You can only draw the conical flask and show the apparatus necessary for us. So, here we have the conical flask. The thistle funnel has to come right to the bottom, whereas the delivery tube will be somewhere here. That is the delivery tube. So here, this is the acid. You have the zinc granules here. So that zinc, then that is HCl. This is the thistle funnel. And that is the delivery tube. So I am not showing the rest of the diagram because the error is here. That is what we have corrected. So make sure that the thistle funnel is long and the delivery tube is above the solution or the reaction mixture inside the conical flask. That is what you have to show. And also we can show the stopper as well, the rubber stopper. So that is the corrected diagram. Is that clear, students? So then we will move on to the next one. 6. Write a simple activity used to identify the gas collected in the gas jar. So what is the gas collected? It is hydrogen. How do we identify hydrogen? We insert a burning splinter. You all know what a burning splinter is. You can use a dry eagle, or like I used in the lab, you can use an instant stick. An instant stick, a joystick. So that can be burned. So with the flame, while the flame is there, you insert it into a test tube containing hydrogen gas. We call it the burning splint or burning splinter. And that will burn off with a pop sound. Why is that? Because hydrogen is a combustible gas. So that is what you have to write here. Here the question is write a simple activity. So we only need to give the activity. So there we can say insert a burning splint. Burning splint into a test tube containing the gas. We can also say containing hydrogen gas because already it's marked there, or according to the question, like they have said, gas collected. So we will just say into the test tube containing the gas. So that is the activity. You insert a burning splint. That's very important. Then the next one. Write the possible observation of the above activity. So I mentioned that it burns off with a pop sound. The burning splint burns off with a pop sound. So that is the observation. Because hydrogen is a combustible gas, it burns, it acts as a fuel, and it burns off with a pop sound. So you can remember that. That confirms it is hydrogen gas. So the burning splinter and the pop sound is very important. So with that, students, we'll move to the next slide. That is extra question 3. During a chemical reaction, new substances are formed from existing substances. So that is the basic introduction to a chemical reaction. You have the reactants, those are the existing substances. From that, the products are formed. Those are the new substances. And you are familiar with the 4 different types of chemical reactions based on the way they occur. The question. Write the evidences for the occurrence of chemical reactions. Write one example for each evidence. What are the evidences, students? You all can remember, we saw many. There can be color change. There can be deposit of solid substances, or what we call as the formation of precipitate. Then there can be different residues remaining. There can be the liberation of gases or effervescence. and also there can be heat change, increase in temperature, decrease in temperature. So these are all changes that can take place. So you need to write down the changes. Those are the evidences. Using those evidences only, you see that there is a chemical reaction taking place. So you have to write that and give an example. So first one I will say color change. Color change in solution. What is the example? Blue color of copper sulfate. Decreases when a piece of zinc reacts with it. So when you put a piece of zinc or even a piece of magnesium into a solution of copper sulfate, the blue color decreases. Then the next one. We can say liberation of gas. Gas effervescence. Effervescence. So you can remember that. What is an example for that? Example, when you put a piece of magnesium or even aluminium, even zinc into a dilute acid solution, you see the liberation of hydrogen gas or effervescence of hydrogen gas. So you can say when a piece of magnesium reacts with dilute hydrochloric acid. Hydrochloric acid. So we can even say hydrochloric acid or sulfuric acid. You can use any other metal that reacts with dilute acids. So you can remember copper does not react with dilute acids. So because of that, you have to make sure it is a metal that reacts with a dilute acid. So that is liberation of gas or effervescence. Then what is the other one? Dissolving of substances. Dissolving of metals or substances. So for that we can give any of those examples. When a metal reacts with acid. Metal like zinc or magnesium react with dilute acids. So even that can be either hydrochloric acid or sulfuric acid. So then, what is the other one we can think of? Formation of a precipitate. So here we can say formation of a precipitate. For that, what is the example you can remember? We did the reaction of barium chloride with sodium sulfate. Then a white color precipitate formed. So example, reaction of sodium sulfate with barium chloride. In this, white color precipitate is formed. White color precipitate is formed. So then you can remember The change in temperature. Change in temperature, it can be the decrease in temperature or increase in temperature. So I will say change in temperature. Change in temperature. So we can say, example, when sodium hydroxide pellets are added to dilute hydrochloric acid. Temperature of the solution increases. So that is an example for increase in temperature. So we have written down many changes. So here you can see, if we go back to check whether I have written everything, color change in solution. So for that we took the example as blue color of copper sulfate decreases when a piece of zinc reacts with it. Then liberation of gas or effervescence, that is when a piece of magnesium reacts with dilute HCl or any other metal that reacts with dilute HCl or dilute sulfuric acid. Then dissolving of metals or substances. Metals like zinc or magnesium, when they react with the acid, you see the dissolving of substances. Even with copper sulfate, zinc dissolves and color of copper sulfate decreases, as well as copper deposits at the bottom. So there you see 3 observations at the same time. So I have told you all this before also, students. Sometimes you see just one evidence, sometimes you get more than one evidences. So then there is the formation of a precipitate. That is a reaction of sodium sulfate with barium chloride. White color precipitate is formed. You all know the precipitate, it is barium sulfate. Then we looked at the change in temperature. Example, when sodium hydroxide pellets are added to dilute hydrochloric acid, the temperature of the solution increases. There is one more that we observed before. They burn with a colored flame. You can remember, when we burnt a piece of magnesium in the Bunsen flame, it burns with a bright white flame. So that is also an evidence. So we can include that as well. Burns with a colored flame. And the example is magnesium burns with a bright white flame. You all saw this activity when I did it in the lab in the same lesson. Magnesium burns with a bright white flame, but we have learnt before, if you can remember, with the properties of sulfur. Sulfur burns with a blue color flame, but normally we don't do that in the lab. Why? Because the product sulfur dioxide is somewhat poisonous. So it is harmful for the environment as well as us. Because of that, we avoid burning sulfur in the laboratory. But when it burns with a blue color flame. That is a characteristic color. So like that, magnesium burns with a bright white flame. So those are the evidences that are used to identify or observe a chemical reaction taking place. So I am sure, students, you were able to list them out, and also you might have written other examples as well, as long as it is relevant to the particular observation that is correct. So with that, students, I will move on to the next slide. Extra question 4. Magnesium reacts with steam to produce magnesium oxide and hydrogen gas. So they have already given you all the reaction. Magnesium, you know, shows different reactions. Now it does not react with cold water. At the room temperature, magnesium doesn't react with water. But when you react magnesium with hot water, what are the products? magnesium hydroxide and hydrogen gas is liberated. But when magnesium reacts with steam, that of course produces magnesium oxide and hydrogen gas. You can remember that. The first one, write the balanced chemical equation for the above reaction. So, you're familiar with this reaction, students? Magnesium with steam. Steam is also H2O in the gaseous state. So, that is why, students, if we include the physical states, you can remember in one of the extra knowledge we discussed that we can include physical state in a balanced chemical equation. So, here if we put gas, then we immediately know that it is steam. Otherwise, from the products, you can identify it is steam. So, H2O will give rise to MgO and H2 gas. So, we need to balance this. Now, one magnesium, 2 hydrogen atoms, 2 hydrogen atoms, 1 oxygen, 1 oxygen. So, it is already a balanced chemical equation. So, they have said write the balanced chemical equation. It is already the balanced one. We have written it. Then the second one. The strip of magnesium should be cleaned with a piece of sandpaper before using it for an activity. Explain this briefly. What is the reason? You are familiar with that. Every time I use a piece of magnesium, I tell you it is a clean one, or I tell you that we have to clean it with sandpaper. I have shown you all that before also. So, what is the reason? Magnesium, if you consider the activity series, potassium, sodium, calcium, magnesium, the fourth metal, it is somewhat reactive, but not very highly reactive like sodium, somewhat reactive. So, when you store it in the lab, what happens? Magnesium reacts with oxygen in air. It is a slow reaction, but when it reacts, the magnesium oxide that is forms a layer over magnesium. And that actually protects the magnesium from reacting further with oxygen. So, the magnesium oxide layer is actually a protective layer. It prevents further reaction. So, that is the layer that has to be removed before the activity. So, that is why we scrape it off with sandpaper. You can remember that. So, they have asked you to explain why we need to clean it. So, here we can say magnesium reacts slowly with oxygen in the atmosphere and forms magnesium oxide. Magnesium oxide, that is MgO. This forms a layer around the magnesium metal and needs to be removed before the reactions. That is why the strip of magnesium is cleaned with sandpaper. Magnesium oxide can be scraped off with sandpaper. So two things, students. One thing, the magnesium oxide layer forms over the magnesium strip. It has to be clean and it can be done by scraping it with a sandpaper. So everything has been included here. Magnesium reacts slowly with oxygen in the atmosphere and forms magnesium oxide. This forms a layer around the magnesium metal and needs to be removed before the reactions. That is why the strip of magnesium is cleaned with sandpaper and magnesium oxide can be scraped off with sandpaper. So here I have given the complete explanation there. So with that, students, we will move on to the next one. Next slide. Extra question 5. Some changes are given below. Write PHY for physical changes and CHE for chemical changes within parentheses. So, you all know to identify chemical and physical changes, students. You all know in a physical change, there is only a state change because the arrangement of constituent particles changes when the substance goes from one physical state to the other. Solid to liquid, liquid to gas, or gas condenses to form the liquid, liquid solidifies to form the solid, or directly the solid can become the gas, sublimation, or gas can become the solid again. So, you are familiar with dry ice where carbon dioxide solid goes to gaseous carbon dioxide. Carbon dioxide gas condenses to form solid carbon dioxide, that is dry ice. You are familiar with all those physical changes. But in a chemical change, what happens? Existing substances are the reactants and they form new substances called the products. So, there is a change of chemical and physical properties taking place. So, when you look at an example, you should be able to identify the two changes. First one, melting of wax. What happens there? The solid wax becomes the liquid wax. So, it's only the physical state change, a physical change. So, we need to write PHY, physical change. Burning of firewood. Now, in firewood, usually there are hydrocarbons. In that, carbon, hydrogen, oxygen, all those are there. And during combustion, carbon dioxide and water vapor are usually released. So, there are reactants in firewood and the products are formed. So, it is a chemical change. Combustion is a chemical change. CHE. Crushing a stone. What happens there? You have a lump of stone, a large physical volume. When you crush it, it becomes powder. So, there the physical nature changes. No other changes taking place. So, that is PHE, physical changes, PHY. Then heating limestone. What happens there? What is limestone? Calcium carbonate. And when you heat limestone, what happens? It decomposes. It is an example of chemical decomposition reaction. Calcium carbonate decomposes to produce calcium oxide and carbon dioxide. So, that is a chemical change, heating limestone, chemical change. Then the fifth one, evaporation of water. Now, water is in the liquid state. When it evaporates, what happens? It becomes water vapor, the gaseous state. So, there it is only the physical state that changes from liquid to gas. So, it is a physical change. Evaporation of water is a physical change. Then the sixth one, heating crystals of Condis. What is Condis? Condis is potassium permanganate. And when you heat potassium permanganate crystals, what happens there? Again, it is a chemical decomposition reaction. Potassium manganate, manganese dioxide and oxygen gas are produced. So, it is a chemical reaction. You are familiar with the equation also. Heating crystals of Condis, chemical reaction. Then the seventh one, condensation of water vapor into water droplets. Here they have explained it directly. Water vapor, gaseous state, water droplets, liquid state. So, state change, it is a physical change. PHY. Then rusting of iron. This I have mentioned to you all before also. Iron, oxygen and water vapor or moisture water, they react together and form a new substance, that is the rust. that is also an oxide of iron, Fe3O4 with water molecules in it. So there the reactants are converted to products. Reactants are iron, water and oxygen. Product is the rust. So it is a chemical change. And there is a change in physical and chemical properties of iron as well. So from that you know it is a chemical change. So it is a chemical change. Melting of wax is physical, burning of firewood chemical, crushing a stone physical, heating limestone chemical change, evaporation of water physical change, heating crystals of condensation is a chemical change, then condensation of water vapor into water droplets is a physical change, and rusting of iron is a chemical change. So with that students, we will move on to the next question. Extra question 6. There are evidences in support of the fact that there had been a wealth of knowledge about extraction of iron in Sri Lanka in the past that we have discussed before. There had been a furnace where they have carried out the smelting process and they have extracted iron and used that to make other objects. So you are familiar with the history. The first question. Write the name of the structure used to extract iron from its ore. So from the iron extraction process students, you all know what is the name of the structure. It is the blast furnace. You can remember it is a structure that is about 60 meters in height. And we pass the hot air blast through the bottom of the furnace and the raw materials are fed into it from the top, and also iron is extracted in the form of liquid or molten iron and slag is taken out, that is to remove the impurities present in iron. So the structure is the blast furnace. Name of the structure, blast furnace. Second one, write an iron ore commonly used to extract iron. What is an ore? You all know it is the solid substance that is present on the earth crust that contains a metal or a mineral of the metal. So iron ore, the common one that is used is hematite, Fe2O3, that is hematite. Write an iron ore commonly used to extract iron. So that is hematite. And hematite, you all know the chemical formula, Fe2O3. This is not compulsory students. If you all write hematite, that is more than enough. But for you all to recall and remember, I have written the chemical formula as well. So then the third one. Write 2 other raw materials needed for the extraction of iron other than the iron ore. So you can remember students, there are 3 raw materials. Hematite contains iron, so we'll be extracting iron from hematite. Then there is coke. Coke is carbon. Why do we use coke? Carbon reacts with oxygen forming carbon dioxide. Again carbon dioxide reacts with oxygen forming carbon monoxide. And this carbon monoxide is the reducing agent or the reductant used to extract iron from its ore, or it reduces iron from hematite. So that is why we use coke. And the other advantage is that when coke burns, there is a large amount of heat released and that helps to increase the temperature of the blast furnace to a range between 1000 to 1900 degrees Celsius. So the second one is coke. And the third one, you all know, limestone. Limestone is what? Calcium carbonate. And why do we use that? Calcium carbonate decomposes to form calcium oxide. And calcium oxide combines with the silica and alumina. Those are the impurities present with hematite. And they form slag. Slag is the way in which the impurities are removed, and also there is an advantage. Slag prevents the reaction of iron with the other substances within the blast furnace. So 3 raw materials, you need to know why they are used: hematite, coke and limestone. So we have already written hematite, so we need to write coke. If you want, in brackets you can write carbon, and limestone, that also we can write if you want calcium carbonate. So coke and limestone are the other two raw materials. With that, students, I will move on to the next slide. Fourth part. How are the raw materials provided to the structure for extraction? How do they provide the raw materials? They are mixed in the correct proportion and they are made into fine powder and introduced from the top of the blast furnace. So that is what you have to write here. They are mixed in the correct proportion and powdered finely, then fed into the furnace from the top. Or you can even simply say the finely powdered mixture of raw materials is fed from the top of the furnace. So that is what you need to write here. Then the fifth part of the question. What is the temperature range in the structure used during extraction of iron? What is that? 1000 degrees Celsius to 1900 degrees Celsius. How is it obtained? The hot air blast that is sent from the bottom, that is about 650 degrees Celsius. It does provide a temperature, but with that temperature, carbon burns, coke burns, and when it undergoes combustion, that also liberates high amount of heat energy. That helps to increase and maintain the temperature between 1000 and 1900 degrees Celsius. So 1000 degrees Celsius to 1900 degrees Celsius. Then the sixth one. How is the temperature range achieved in the structure? So I just answered this question for you all. One is using the hot air blast and the other one the heat released when coke burns in oxygen. So both of those help to achieve this temperature range. So we can say the hot air blast sent in from the bottom and the high amount of heat released when coke burns with, or we can say burns and reacts with oxygen. So from both these methods, one is the hot air blast, the other one is the burning or combustion of coke. So from those they achieve this temperature range. Is that clear, students? So then we'll move on to the next part of the question. 7. Write the balanced chemical equation for the extraction of iron in the above process. So you're familiar with that. What is the form in which iron is present? It is hematite Fe2O3. So we have Fe2O3 there. And what is the reductant or the reducing agent? It is carbon monoxide. And from there we get Fe and carbon dioxide is released. So if we are to balance, now here you can see 2 Fe, 3 oxygen, 1 oxygen there. So here we already have 2 oxygens. So what do we need to do? We need to have 3 carbon dioxide. In order to balance that, we have 3 carbon monoxide, and also to balance iron we need to put a 2 there. So Fe2O3, since there are 3 oxygens, to remove those 3 oxygens, we need 3 carbon monoxide, and that releases 3 carbon dioxide molecule, and because there is 2 Fe there will be 2 Fe atoms there. So that is the balanced chemical equation. Fe2O3 plus 3CO gives rise to 2 Fe plus 3 CO2. Then the 8th one. What is the reducing agent in the above reaction? Reducing agent. So I have mentioned this reducing agent, reductant, that is carbon monoxide. Carbon monoxide. You can write the name or you can write it as CO, carbon monoxide. Then the next question. Write the main product and byproduct of iron extraction. What is the main product? Main product is molten iron or liquid iron. So main product molten or liquid iron. So here also students, you don't have to write both terms. I am writing it so you become familiar with those. So you can either say molten iron or you can say liquid iron. Then what is the byproduct? Byproduct. One thing you all know, when limestone decomposes, there is calcium oxide produced, and this calcium oxide reacts with the impurities silica SiO2 and alumina Al2O3, and that forms slag. Slag is taken out from the blast furnace. That is a byproduct. And also during the reaction, when calcium carbonate decomposes, carbon dioxide is produced. There also carbon dioxide is produced. When coke react with oxygen also, carbon dioxide is produced. But that carbon dioxide again reacts with carbon and forms carbon monoxide. So from all these 3 reactions, there is carbon dioxide produced inside the blast furnace. Most of it or part of it, you can say, is converted to carbon monoxide that acts as the reducing agent. But there will be a certain amount that will be released from the blast furnace as well. That is why we show it as waste gases at the top. From the top only the gases are evolved. So there, that is also a byproduct. So we can say byproduct slag and carbon dioxide. Carbon dioxide. This also, if you want, you can write the chemical formula CO2. Slag also you all know, calcium aluminate and calcium silicate. Calcium aluminate, you know, CaAl2O4 and calcium silicate CaSiO3. So like that, you can write the chemical formula also, but it's easier to say as slag and carbon dioxide. With that, students, I will move on to the next slide. 10. What are the impurities present in iron ore? So I have told you all this before. What are the impurities present? Alumina is Al2O3. This is known as alumina, or we can say aluminium oxide. Aluminium oxide. Then there is silica SiO2, or what you call as silicon dioxide. Silicon dioxide. Aluminium oxide or silicon dioxide, silica. So then the 11th one. How are the impurities removed from iron ore? How do we remove that? When these 2 substances react with calcium oxide formed from calcium carbonate, they form slag. So slag removes the impurities. So we can say they react with calcium oxide and form the slag. Slag is removed from the slag out above, iron out. So that is how the impurities are removed. They are removed in the form of slag. That is the important thing. So you have to mention this slag. So then we have the last question. What is the advantage of the existence of the substance you mentioned in part 11 above during extraction of iron? This is part 11. This is the substance you mentioned there. Slag. What is the advantage? You can remember, students, slag is lighter than molten iron. So molten iron goes down, slag remains above molten iron inside the blast furnace. So that is an advantage. Why? Because molten iron is in the liquid form, very high temperature. Inside the blast furnace also very high temperature, and there are other substances. The raw materials are there, carbon dioxide, carbon monoxides, so many other substances. So this slag prevents the reaction of iron with the rest of the substances in the blast furnace. So that is an advantage where we can extract the pure iron in the liquid form. So there we can say slag prevents the reaction of molten iron with other substances, or you can even say impurities present in the blast furnace. This is one way of writing it. Or you can say slag prevents the oxidation of molten iron with other substances. So how is this possible? Because slag remains above molten iron in the furnace. So because slag is above molten iron in the furnace, it is able to prevent the reaction. So that also can be included. It is able to prevent the reaction of iron, of liquid iron. So that is the advantage of slag being in the blast furnace. So can you all understand that, students? Is that clear to you all? Okay then. Extra question 7. Activity series can be used to decide on the method suitable for the extraction of metals. You can remember that, students. We have the activity series. Can you recall the metals of the activity series? Potassium, sodium, calcium, magnesium, aluminium. Then what do we have? After aluminium, we have zinc, iron, tin, lead. Then there is hydrogen. After hydrogen, copper, mercury, silver, platinum and gold. Out of those, if you can remember, students, the metals at the top, potassium, sodium, calcium, they are highly reactive elements. So what happens there? They exist in the form of compounds and usually methods like electrolysis is used to extract these metals from their compounds. But the moderately reactive metals like zinc, iron, copper, tin, lead, those are present again in the form of compounds and they need to be extracted using an element or a compound. We just discussed the extraction of iron before this. So, we use a reducing agent to reduce the metal from its compound. So, the reducing agent can be an element or a compound. Then we have the metals at the bottom, silver, platinum and gold. So, what happens to them? They exist as native metals. Why? They are very, very less reactive. They don't usually form compounds. They exist as metals. So, they need to be separated from their impurities present in the ore. For that, what do? We use simple physical separation methods like sifting. So, those are the ways in which we extract or separate metals from their naturally existing forms. So, for that we use the activity series. You can remember that. So, the question, write the methods of extraction of the metals given below from their ores using the activity series. So, because they say using the activity series, it is not a must, students, but I told you all the activity series. We will also write it down. Potassium, sodium, calcium, magnesium, aluminium, then we have zinc, iron, tin, lead, then we have hydrogen, after that we have copper, mercury, silver, platinum and gold. So, as you go down, the reactivity increases and it is the descending order of reactivity. So, here you can remember these are the highly reactive metals. These are usually the moderate reactive metals and these are the reactivity decreases down the activity series. So, you all can remember that, students. So, what is the first method? Sodium. How do we extract sodium? Electrolysis. By electrolysis is of sodium compounds. Chloride. Now, this is how sodium is usually present. You all know in seawater there is lot of sodium chloride. So, we take sodium chloride, salt turn method, get the salt and then the salt is made into liquid sodium chloride and the electrolysis of liquid sodium chloride produces sodium metal. Then gold. Like I said, simple physical methods like sifting. Simple physical methods like sifting. Then how do we separate zinc? Now we have discussed the separation of iron. But you all know like iron, zinc is also a moderately reactive metal. Then we separate it using an element or compound reacting with its compound. So, we can say zinc is reduced from its ore by an element or a compound. What do we call this element or a compound? It is known as the reductant or reducing agent. So, by reducing the zinc from its ore using an element or a compound. So, those are the methods of separation based on the activity series. So, I am sure you all can understand that. And I am sure, students, you would have written down the correct answers. So, with that, students, I am going to end this chapter and in the next chapter also I will discuss some more extra questions.